Hi everyone, welcome to Connect. Here to talk to you today is myself, Sam Redman, and Patrick Stevens. We're here to talk to you about creating a local multi-node Couchbase deployment on your laptops, not in the cloud, not on infrastructure in your data center, so that you can test your code as fast as possible and develop new features. So getting straight into it, here's our agenda for today. First off, we're going to talk about accelerating operations with autonomy. So the sort of what and why as to why there's a need for this feature within your production database. We're then going to talk about using Kind and Helm, a quick overview of demo of Kubernetes and everything which is going to be ran locally. And then finally, we're going to have a wrap up of an SDK demo. So straight into it, accelerating operations with autonomy. So the what and why as to why we're here and developing code and pushing it out to a local instance of Couchbase. So we have some issues with classic database deployments. So first off, database silos. So microservice adoption has left databases behind and your database cannot scale at the same pace. The issue here has been that developers have made new web applications. If they need more to run on the application, they add more containers. If they need to add new features, you just deploy a new container with those features. There's been a big push with cloud vendors and everyone moving their infrastructure and services over to cloud vendors. But the issue here is that if another cloud vendor releases a new feature which you need for your application, you've either got to have things running in parallel or pay the costly price to move all your code over. And there's little industry standardization to move things across here. So what you end up with is essentially lock in to a specific vendor. There's high operational costs. So with deployments, you've got all these complexities of hundreds of applications and databases. So there's huge sprawl in order to meet the needs of both your customers and applications. This, in fact, is compounded when you talk about moving across multiple geographies. So you've obviously got to handle things in remote data centers, handle latency, lots of features which you need in enterprise applications but are costly to support. So all of these applications which you need to support essentially reduce your agility. The final one is specialist database expertise. So databases believe they're special, so you need to be prepared to hire an expert or become one. This can be a costly exercise with all of the training needed, all of the new accreditations and things like that, which you need to have. Really and truly, you need a database which can just meet your needs, whether that's operationally or from a perspective of what your application needs. So we at Couchbase have the Autonomous Operator, and we believe that this provides some fantastic remedies for some of the issues which we've seen out in the field. So first off, app and database side by side. You can deploy Couchbase in Kubernetes with your microservices. You can scale it alongside all of your containers, both up and down, so that then when you have a sudden surge, you can therefore just scale a cluster. You can do that automatically or manually. The great thing here as well, when we talk about cloud vendors, so there's no more cloud vendor lock-in. And because you have essentially deployed on Kubernetes, you can lift and shift from one cloud vendor over to another because all of the cloud vendors fantastically support all of those Kubernetes platforms. So essentially, your database can be as mobile as your application containers. It's deployed alongside it, therefore it can lift and shift to other cloud vendors. In the bottom left, we've got move with agility. So essentially the fact that we can just deploy new features with ease. Because Couchbase is schemaless, you can essentially just deploy these new features. There's no need to update schemas in the database or to have downtime. It can just start taking traffic for this new application feature with new fields and documents. So essentially, the fact that the final compounding factor of moving with agility is that you can get your database pipeline in your environment. So essentially, when you've got a new feature, you can fire up a Kubernetes operator instance on your laptops and just test the code. Finally, when we were talking about database experts, I believe the operator is the best SRE ever. So hire it as your Couchbase expert. If it's configured correctly, the operator will just make it happen for you. It doesn't get grumpy. It doesn't get grumpy when it has to be woken up at 4 a.m. to fix a production issue. It just works. Final slide here. I'm going to talk about operator maturity. So obviously on the Kubernetes platform, there's lots of different operators from lots of different vendors. These different operators have lots of different capabilities. So there's basic install, seamless upgrades, life cycles, deep insights, and then finally at the top tier is autopilot. Now, Couchbase's operator operates at autopilot. So this means that we can support horizontal and vertical scaling, auto config tuning, abnormal detection, and schedule tuning. So really and truly, when you're looking at operators which are offered by different database platforms or NoSQL platforms, ensure that it operates at the highest level possible, because it means that you will have to have the most minimal interaction. Over to Patrick.
Okay. Hi, everyone. I'm Patrick. I'll talk to you quickly about what Kind and Helm are and how we're going to use them in our automation pipelines. So what are Kind and Helm? So Kind is Kubernetes and Docker. So it's a way of running a full Kubernetes cluster locally all through containers. So essentially the worker nodes, the control plane nodes, everything is run as containers. And it gives you, you can run multiple clusters as well. You can run them at different versions of Kubernetes. You can do lots of different things. You can also load images straight into the cluster. So rather than having to pull stuff from a registry or deploy a local registry, we can do like a Docker build locally, push it into our local cluster, use it straight away before we then have to transition it to any kind of production environment as well. Because it's a containerized deployment as well, it's potentially faster and a bit more lightweight than a VM, but that does depend on whether you are running a container environment that doesn't need a VM. Like macOS has to run containers through a VM, so it's not quite the same. It follows a kind of cattle rather than pets approach of infrastructure as code. So rather than try and have like this handcrafted set local cluster, just destroy it, recreate it, and it always creates it in the same way. You don't have to worry about it so much. It's fully integrated into our CI/CD and quite a few other people's as well. The other benefits it has over something like Minikube as well is it's got its own REST API. So a lot of people use it programmatically as well, driven through their CI/CD pipelines. There's a few alternatives I touched on. So Minikube is sort of a VM version of it. Minikube and Kind are both Kubernetes SIG projects. So they're open source. There's also K3S from Rancher, which is another alternative as well, which is a good option. And certainly I know some of our developers here use K3S too. Helm is the package management system essentially for Kubernetes. It allows you to package up and deploy like full applications with a simple Helm chart. It's kind of a simple and effective way to get a working out of the box solution. So certainly very good for just doing POCs and testing things out and just deploying something like that. I'm not necessarily convinced it's a good way to handle ongoing, very configurable deployments like Couchbase, but it's a good way to get something very simple going just to try it out. It does have a few issues with upgrading, particularly of custom resource definitions and the like, but it is still quite good. If you're going to use it in production, it might be better to have the full control and flexibility of configuring those CRDs directly. At Couchbase, we use the operator to manage our Couchbase clusters. The Couchbase Helm chart packages all that up. So what the Couchbase Helm chart does is provide you a complete solution that you can deploy from scratch. So it deploys the dynamic admission controller, the operator, and also a set of default configuration just to give you a working cluster. There's some examples for backup and restore, and it's fully configurable too. So we also have just some quick examples of this is how we use it on our CI/CD pipeline. We have a matrix job there where we run Kind clusters of different versions of Kubernetes just to ensure validation works on all of them. And then there's a much larger acceptance test that's also run through all of them. We've got other usage as well. So actually the Helm chart uses Kind as a GitHub action. So when we publish or someone provides a PR for the Helm charts or we want to do a release, it creates a Kind cluster, runs all the unit tests, runs some deployment checks, and then releases the chart into the repository. So it's just another example of how we use it. Right, and now we're going to continue on to a quick demo of running our Kind multi-node cluster. So in this instance, the repo we showed earlier has all the details, but I'm going to show you a live example of it all running. So the reason I wanted to show you this is to go from nothing, no cluster at all, no Kubernetes deployment at all, to a fully working Couchbase managed cluster. It's 2 lines of code. So you have one to create the cluster, so kind create cluster, and then use the Helm chart with a single line to install our Couchbase cluster. That's all you need. So that's the entirety of this demo. I fleshed it out a little bit. You'll see there's a bit more stuff in there to show you examples of configuring a multi-node cluster. So by default, kind will create a single node cluster, but maybe you want some worker nodes and different configuration, which you can provide through that. I'll also show you how to push images to it, and then some of the configuration for the Helm chart. So this is the demo going now. So that's the script from the repo we highlighted earlier. So I'm just showing you all the different commands. So this is how you add the Helm charts. There's quite a lot of stuff there, but it's mostly comments. And then I've just got a wait at the end to make sure the full Couchbase cluster is running. So we're going to create our cluster. It's very simple. So we delete an old one if it exists, and then we create the new one. Off it goes. This takes a little bit of time, so we've sort of sped it up a little bit for the demo, but it shows you it all going. And you can kind of see on the other screen there, everything running. Now we push in our Couchbase server image. So this is quite a useful little trick to speed things up. And then we use the Helm chart to deploy it all. And so this is the Helm, so everything's deployed now. We've got a fully running system. And I've done port forwarding to show you the UI of Couchbase server. So this is the instance we've deployed. I copied the randomly generated password, and we log in now. And you can kind of see, the standard Couchbase cluster UI with 3 servers there. So by default, the Helm chart gives you a 3-node Couchbase cluster with all the services enabled, but you can configure that too. So these are just the defaults from the Helm chart. And you can see the CRD that defines that Couchbase cluster. So this is the full definition of it. You can kind of see the services there and their size, their name as well. So you can even use the Helm chart, deploy it, and then go in and edit it. And any changes you make here, the operator will pick up and apply to your cluster.
So now that we've got a fully functioning cluster available locally on our laptops, we are now able to fire up a demo environment, essentially a dev environment where we can run our code, run our tests, and make sure that everything's working as expected, deliver new features, test regression, all these fantastic things, all done locally without any heavy infrastructure. So straight into it, first of all, we have a Docker file. So this Docker file essentially just says, this is what my container wants to look like, which I'm going to use as my demo environment. So here we're going to have a quick run through of what we've got. It's basically just a standard node image. So we're going to use the Couchbase Node SDK. We're going to install just a couple of packages. So I wanted to be able to test the fact that our containers, so our dev container, could actually communicate with the Couchbase cluster. So if you do hit any issues, you've got a bit of troubleshooting tools there. We're specifying a work directory. So essentially, whenever we enter this or run any commands, do them within this /user app directory. We're going to then install the Couchbase SDK as per the SDK instructions. So these are all available for each SDK on our site, and I'll put a link in there for you. This is a bit of a hack now. We're just running a sleep command so that then we've got something to attach to. The other half of our development environment scripts, this is something which Patrick very kindly created for us. And what it will do is grab this Docker file, build it for us, make a deployment, so Couchbase SDK dev. It will then ensure that this deployment's rolled out. And then obviously we want a pod there to consistently be up as per the deployment configuration. So this is the pod name. We're going to use this pod name now a few times in the couple of commands. So what we're essentially trying to do is just copy our code, copy our dev code over. Obviously, you can automate this. This is just a demo. So we're doing that. Once that's carried out, we're then going to actually just jump in the terminal, run our code, and have a poke around, make sure that everything's as per expected. Obviously, your pod name might be similar. So you can see here that we are now within the shell of the pod, and I'm just going to show you the fact that we've successfully copied the code over. So I've got this Node Couchbase project. This is essentially a similar example to what we've got on our docs. And you can just see here, we've got this index.js file. So I'll just give you a quick run through on Vim. Sorry about to show you what is actually within this code. So it's nice and simple. And there's a few things which you'll need to edit to meet your cluster definitions. So for an endpoint, we are going to use the SRV. This is provided by our operator. So it's essentially just a consistent name for our clients to connect to. So we know that we always got our cluster name, and then at the end we've got -SRV. The next section, which you're going to have to change, is the admin credentials. So essentially, when you fire up your deployment, you should be greeted with what credentials you have created for your administration user. So this is on a per deployment basis. There's no point creating an exact script. If you have lost your creds, you can just run Helm, get or Couchbase, and it will grab you those creds again. The next thing, we've got our bucket name. So we just get supplied with a default bucket here, and then we can use that in order to get a default scope and a default collection. So it's nice and easy. It's going to be a bucket of default, a default scope, and then a default collection. So next up, we're just going to show you a quick run through of the fact that we can run Couchbase code. So we're going to perform a upsert. We're going to perform this upsert on the bucket. We're then going to load the document because it's Couchbase and it's worked for us. So it will then get it and print it out for us. So next off, you can see here that we have ran the code, we rebuilt and ran the code, and you can see that it has managed to both upsert and then print out and get the document. So a bit of port forwarding here. I'm going to flick over and show you the Couchbase GUI. So obviously, again, use those same creds. So we head over to buckets and we can see that we've got one item. So fantastic. We've tested our code. We've done it all locally. We've not had to fire anything up in IaaS. We've not had to wait for DevOps to give us a little dev environment, and we've not had to manage anything for ourselves. I really, really enjoy the fact that we have this in Couchbase, especially coming from an engineering background where my development environment was hosted and managed by myself, and it was just so painful, and it was part of my day job to keep it up to date and also develop new features and code. So hopefully we've provided you a really useful and great technique to test code on an actual Couchbase instance rather than having to manage your own Couchbase test. So thank you very much. This has been hopefully a really useful session for everyone at Connect. I hope you've enjoyed all the other sessions. A big thanks to Patrick for putting this all together and holding my hand. So a little bit of contact. Over to Patrick. He's first up.
Yep, so I'm Patrick. Obviously, you can see my email there, patrick.stevens@couchbase.com. We've also got the Git repo up there as well.
Thank you. So Sam Redman, obviously my email's there. If you have any needs from a sort of pre-sales / solutions engineering point of view, please drop me a line.